We are going to start now the next lecture, lecture 13 of class 11th mathematics, chapter 3, trigonometric functions. In this lecture, we will study some graphs related to the trigonometric functions. So the first graph we are talking about over here, it is the graph of the function sine of y is equal to sine of x. So to plot this graph, we know the domain of the function sine x, it is r, and the range of this function, it is from -1 to 1. So in place of drawing the graph of the function for all the real numbers, we are restricting to draw the graph in the interval 0 to 2 pi, because we know that the period of the function sine x, it is 2 pi. So whatever the graph of the function is in this interval 0 to 2 pi, the same graph will be in the next interval from 2 pi to 4 pi. Same graph will be for 4 pi to 6 pi. So it means if we plot the graph of this function in this interval 0 to 2 pi, then by repeating the graph on the intervals of length 2 pi, we can obtain the graph of the function on for all the real numbers r. So first of all, we plot the graph of the sine x for the interval 0 to 2 pi. So these are the values shown over here corresponding to this. So we are saying for x is equal to 0, the value of sine x, it is 0. For x is equal to pi by 6, the value of sine x, it is 0.5. For pi by 3, it is 0.87. For pi by 2, it is 1. We have plotted these points on this graph. So we are saying corresponding to 0, the value we have, it is 0. Then corresponding to pi by 6, the value we have, it is 1 by 2, that is equal to 0.5. Next, corresponding to pi by 3, the value we have, it is 0.87, and this is the value 1 corresponding to pi by 2. So this is the portion of the graph in the first quadrant, we are saying, for 0 to pi by 2. Then after that, we are saying for 2 pi by 3, the value will be again 0.87. For 5 pi by 6, the value will be 0.5, and for pi, the value is 0. So this is the portion of the graph in the second quadrant. Further, moving towards the third quadrant, we obtain that the values of sine x, they are negative. So we are obtaining the graph in this form. And then in the fourth quadrant, when we are saying this is the graph of the function in the fourth quadrant, and in the fourth quadrant also the values, they are negative. So if we join all these points, we obtain the graph of the function sine x in the interval 0 to 2 pi in this form. Now if we want to extend this graph, we have to draw the same graph for the interval 2 pi to 4 pi, because we know that sine of theta plus 2 pi, that is equal to sine of theta, or we are writing it is 2n pi, where n belongs to z. So this is the graph of the function sine y is equal to sine x in the interval 0 to 2 pi. Next is, if suppose we know the graph of some function y is equal to fx, and we have to plot the graph of the function y is equal to fx plus k, then what we have to do is we have to shift the graph mod of k units upward or downward. We will move it upward if the value of k is positive, and we will move it downward if the value of k is negative. So this thing is explained over here. This thing is explained over here. We are saying, suppose this is the graph of the function given to us. We are talking about this graph over here. The function y is equal to fx. This is the graph of the function y is equal to fx. If we want to plot the graph of the function y is equal to fx plus a, where a is some positive number, then we are saying we have to move each point a units upward. Suppose I am talking about this point over here, we have to move this point a units upward. If we are talking about this point is moved a units upward. If we are talking about this point is moved a units upward. So the graph we obtain for y is equal to fx plus a, it is this graph we are talking about. This is the graph for y is equal to fx plus a. Similarly, we have to plot the graph for y is equal to fx minus a, where a we are saying it is greater than 0. Then the graph we have it is, we have moved all these points a units downwards. Each point we have to draw a unit downward and we obtain this graph. So we give an example over here. The first example we have, this is the function given to us. We are talking about this is the function y is equal to e raised to the power x. This function is given to us. This is the graph of y is equal to e raised to the power x. This we have already seen. Now suppose we have to draw the graph of y is equal to e raised to the power x plus 1. So we are saying this is plus 1 over here. So every point will be shifted by 1 units upward. So the graph we obtain in this case, it is this graph, that every point over here, we are saying this point earlier it was 1, it is shifted, this point it is 0 comma 1, it becomes 0 comma 2. We have added 1 to the y coordinate and we obtain, this is the graph of the function y is equal to e raised to the power x plus 1. Next, if we have to plot the graph of y is equal to e raised to the power x minus 1, we will shift every point 1 unit downward and we obtain, this is the graph for y is equal to e raised to the power x minus 1. The next example we have, this is the function given to us. We are saying the function we have, it is y is equal to mod of x. The graph of y is equal to mod of x. This is the graph of y is equal to mod x. This is by the definition of this function. We know that mod x is defined in the form, it is x if x is greater than equal to 0, it is minus x if x is less than 0. This is the function y is equal to mod x we are talking about. Now if we shift this graph, we want to plot the graph of mod x plus 2. We want to plot the graph of mod of x plus 2. So every point will be shifted 1 unit upward. We are saying this is the point 2 units upward, this is the point 0. This is shifted 2 units upward, it reaches the point 2. This is the point we are talking about corresponding to 1, it reaches this point. This is the point corresponding to 2, this reaches this point. So the graph we obtain over here corresponding to the function y is equal to mod of x plus 2. This is the graph of the function corresponding to the function y is equal to mod of x plus 2. Similarly, if we have to plot the graph of the function y is equal to mod of x minus 2, this is the graph of mod of y is equal to mod x. This is the graph of y is equal to mod of x. We have to plot the graph of y is equal to mod of x minus 2. So every point will be shifted 1 unit downward. So this is the graph we obtain by shifting every point 1 units downward. So what we have done over here, this was earlier, this was the point 0, now it has reached to the point it is minus 2. So this is the graph of y is equal to mod of x minus 2. This is the graph of y is equal to mod of x. Next is, if the function y is equal to fx is given and we have to plot the graph of y is equal to f of x plus k. This case it is different from the previous case. In the previous case we were having the function y is equal to fx and we were drawing the graph for y is equal to f of x plus k. In this case we are having y is equal to f of x plus k. Now this k is being added to the elements of the domain. So we are saying in the previous case, when we are talking about this case, we are saying the value of k, this is being added to the values of y. So we have shifted the graph upward or downward, that is in the direction of y. Now this k is being added to x, it means the graph will be shifted in the direction of x. If this k is positive, suppose I am talking about the graph of the function, say y is equal to x, I am plotting over here the graph of the function. This is y is equal to x. The value we have over here, it is 1. Corresponding to this 1, the answer we will have over here, corresponding to this 1, the answer we have over here for y, it is 1. Now suppose I am changing this function to y is equal to x plus 1. So what will happen over here? We are talking about this value of y. We are saying when this value will be attained, if I substitute y is equal to 1, I will obtain x is equal to x plus 1. So this will give us x is equal to 0. So we are saying earlier this value 1 was attained when x was equal to 1. This value y is equal to 1 was attained when x was equal to 1. When we have changed the function to y is equal to x plus 1, we are saying this value 1 is attained when x is equal to 0. We are saying this point, the graph will move from this point. When we are saying value of y is 0, when we are calculating for value of y is 0, we get x is equal to minus 1. Over here we are saying the value of y is 0 when x is equal to minus 1. So the graph of this function will be in this form. So what is happening over here? We are saying the values of y, they are attained in advance. In advance means earlier this value 1 was attained when x is equal to, we are saying the value 1 was attained when x is equal to 1. Now this value of y is equal to 1 is attained when x is equal to 0. So what we are saying over here is when this k is positive, then we are calling it as advance, and we are saying that the graph will be shifted towards the left. This whole graph, this is shifted towards the left side. And when we are talking about this value of k is negative, then we have a delay. Delay means this graph will be shifted towards the right hand side. So this thing will be more clear to you with the example over here. So this is our first case we are talking about. So suppose the function that is given to us, it is y is equal to fx. This is the graph of the function. If we have to plot the graph of the function y is equal to f of x plus a, we are saying every point is shifted towards the left hand side. So this point over here, this is shifted towards left hand side. This point over here, this is shifted towards left hand side by an amount of a. This point over here, this is shifted toward left hand side. So our graph, it gets shifted towards the left hand side, and we obtain the graph in this form. Similarly, if we have to plot the graph for the function y is equal to f of x minus a, we are saying corresponding to each point over here, if I am talking about this point, it is shifted towards the right hand side. This point, it is shifted towards the right hand side. This point, it is shifted towards the right hand side, and the graph we obtain in this case, it is this graph. Every point, it is shifted towards the right. So this is how we can plot the graph of the function y is equal to f of x minus a. Now suppose we are plotting the graph of y is equal to mod of x. This is the graph of y is equal to mod x. If we have to plot the graph of the function y is equal to mod of x plus 2, what we can see from here is that this value of, we are talking about, so the value of k we have over here, it is 2 and it is greater than 0. It means graph will be shifted towards left by an amount of 2. So this point over here, this is shifted towards left by an amount of 2. This point, it is shifted towards left by an amount of 2. This point is shifted towards left by an amount of 2. This point is shifted towards left by an amount of 2. This point is shifted toward left by an amount of 2 units. So the graph we obtain from this is the graph we are talking about. So whole of this graph y is equal to mod x, it is shifted towards the left hand side by the 2 units. Next is the graph corresponding to the function. We are saying y is equal to mod x is there. If we have to plot the graph corresponding to the function y is equal to mod of x minus 2. So we are saying in this case every point will be shifted towards the right. Every point over here, this is shifted towards the right hand side, and the graph we obtain in this case, it is this graph. So this is the graph of the function. This whole graph, it is shifted towards the right by 2 units, and this is the graph of the function y is equal to mod of x minus 2. Next we have, if the graph of sin x is given, this is the graph of sin x is given to us. We are talking about this is the graph of y is equal to sin x. If we have to plot the graph of y is equal to sin of x plus pi by 4. So what we are doing, we are shifting this graph by an amount of pi by 4 towards, we are talking about this point over here. This point we are saying, this is the point 0. This point is shifted to the point minus pi by 4. This is the point minus pi, it is shifted to the point minus pi by 4. So every point it is shifted towards the left hand side by an amount of pi by 4, and the graph we obtained in this case, it is this graph we are talking about. This is the graph of the function we have obtained in this case. That is by shifting all the points, or by shifting the graph by pi by 4 units towards the left hand side. Next we have is again the graph of the function sin x is given to us. This is the graph of the function sin x we are talking about. If we have to plot the graph of the function y is equal to sin of x minus pi by 4. Now it is minus sign over here, it is minus pi by 4 over here. So we are saying the graph will be shifted towards the right by the amount of pi by 4. So the graph we obtain in this case, we are saying every point that will be shifted by an amount of pi by 4. Earlier this point was 0, now it is shifted to the point pi by 4. Similarly this point was there, it is shifted to shifted by an amount of pi by 4 on the right hand side. This point is shifted by pi by 4. Similarly every point over here, this is shifted towards the right hand side by an amount of pi by 4, and the graph we obtain in this case, it is this graph. The graph we obtain in this case, it is this graph. This is the graph of the curve y is equal to sin of pi x minus pi by 4. So these are the, this is how we can draw the graph of y is equal to f of x plus k if we know the graph of y is equal to f of x. Next we are going to plot now the graph of y is equal to cos of x. So first of all we are looking at the axis over here. This is our y axis and this is our x axis. We are drawing the graph of the function y is equal to sin x. So this is the graph of the function we are talking about, y is equal to sin x. This thing we have already seen, that how we can plot the graph of the function y is equal to sin of x. What we have done, we have plotted the graph in the interval 0 to, this is 0, we have plotted the graph from 0 to 2 pi, and we have extended this graph for the on the whole of the real line, and this is the graph of the function y is equal to sin of x. Now from this graph we can plot the graph of y is equal to sin of x plus pi by 4 or y is equal to sin of x minus pi by 4. So the graph we obtained for y is equal to sin of x plus pi by 4, it is this graph we are talking about, this graph. This is the graph we are obtaining for y is equal to sine of x plus pi by 4 or sine y is equal to sine of x minus pi by 4. We have what we have to do if we are drawing the graph for sine of x plus pi by 4. We have to shift this whole graph by pi by 4 units towards left, and if we are drawing the graph for sine of x minus pi by 4, we have to shift the graph on the right hand side. Next, the third case we are talking about, if we plot the graph of y is equal to sine of x minus pi by 2, so the graph we obtain, we are saying it is, we are shifting this graph towards the right hand side by an amount of pi by 2, and the graph we obtain, it is of this form. This form we are talking about. And similarly, we can plot the graph of y is equal to sine of x plus pi by 2. And we know that the value of sine of x plus pi by 2, that is equal to cos of x. So the graph of cos x, this graph is shown over here. It can be obtained from the graph of sine x by shifting that graph towards left or right by an amount of pi by 2. So this is the graph of the function cos x shown over here. So how this graph is being obtained? We are saying this graph is obtained by shifting the graph of the function. The graph of the function sine x we will have, it will have value 0 over here. It will have value, the graph of the function sine x, it is of this form. So what we are saying, we have shifted this graph towards the left by an amount of pi by 2. So this 0 is shifted to minus pi by 2, pi by 2 is this shifted to 0. So all these points, these all points we are talking about, these all points, these have moved towards the left by an amount of pi by 2, and we obtain the graph of the function cos of x in this form. So it is easy to see that how we have drawn the graph of the function cos x from sin x. So we just have to shift the we are saying you can shift the x's, or we are saying we have shifted the graph of the function towards the left by an amount of pi by 2. I am again explaining this thing over here. We are saying, suppose these are the axes we are talking about. These are the axes we are talking about. This is our x-axis. This is the y-axis. We have plotted the graph of the function sin x in this way. Now, if we want to plot the graph of the function cos x, one thing we can do is we have to move these all points towards left, or second thing we can do is we can draw new axis over here. Suppose I am drawing the axis in this form, that I have shifted the y-axis from this point, from this line to this line, and this distance we are saying this is pi by 2. Now this is our x-axis and this is the y-axis. So the graph we obtain, this new graph we are talking about, it is of this form, and this is the graph of the function. This is x-axis, this is y-axis. We have shifted the axis towards the right by an amount of pi by 2, and this is the graph of the function cos of x. So you can see it in any ways. You can calculate, see it in this way, that we are talking about y is equal to sine of x plus pi by 2. We are shifting the graph towards left by an amount of pi by 2. Or you can see this condition in this form, that we have shifted the axis towards the right by an amount of pi by 2, and we obtain the graph of cos of x. Next is we have to plot the graph of the function y is equal to tan x. We know that the period of the function tan x, it is pi. So first of all, we are going to draw the table or write the table corresponding to different values of angles for tan x. So we know that if x is equal to 0, the value of tan x it is 0. For x is equal to pi by 6, the value we obtain it is 0.58. For pi by 4 it is 1. For pi by 3 it is 1.73, and for pi by 2 it is infinity. So if I plot the graph from 0 to pi, I am talking about the graph of tan x from 0 to pi, we know what we can see from this is the value at 0 it is 0. The value at pi by 6 for this angle is over here, it is pi by 6. Then we have angle pi by 4, pi by 3, and then pi by 2. This is the line corresponding to pi by 2. So we are, what we can see from this, that the values they are increasing and they are going up to infinity. So the graph of the function is in this form. This is at the value 0 and this is at the value pi by 2. Next we are plotting for the points pi for the interval pi by 2 to pi. We are drawing the line over here. Now what we can see is corresponding to pi, the value we have it is 0. Corresponding to 5 pi by 6, the answer we have it is minus of 0.58, then it is minus of 1, then it is minus of minus of 1.73. So these values, these are increasing. These values, these are increasing. So what we can see from this is that the graph in this portion, it is in this form. So this is the graph of the function tan x. We are saying from the interval 0 to pi by 2, the values they are increasing. And when we are talking about the values from pi to pi by 2, these values, these are decreasing and they are going towards the minus infinity. So this function, this is not defined for the value pi by 2. This function, it is not defined for this value. It is not defined in this region. Now further we know that this function is periodic with the period pi. So it means the next thing we have to do is we have to plot this portion over here. So the graph will be like this, and this portion, if we move towards this side, this will be plotted in this way. So the graph of tan x we obtain in this form, that is from minus pi by 2 to pi by 2, the values they are increasing from minus infinity to infinity, and then from pi by 2 to 3 pi by 2, the values they are increasing from minus infinity to infinity. So this is the graph of the function tan x, and it is important to note over here that the function, the values, they are not defined for the value pi by 2, 3 pi by 2, minus pi by 2, minus 3 pi by 2. This function we are talking about y is equal to tan x is not defined at these points, as these values, these are approaching to infinity or minus infinity. Now the next thing we have over here, suppose a function fx is given, y is equal to fx is given, and we are given the graph of this function. This is the graph of the function y is equal to f of x. If we have to plot the graph of the function y is equal to minus f of x, then we are saying we have to flip the graph of y is equal to fx about the x axis. So flip the graph means if the coordinates of the points we are talking over here, this is the point on the x axis, so it will remain over here. Suppose I am talking about this point on fx, this point, this is corresponding to a comma f of a. So the coordinate of the point corresponding to this function minus f of x, it will be something over here corresponding to a. We will have it is a comma minus f of a. So what we have done, we have taken, this is the x axis we are talking about, we have flipped all the points with respect to the x axis. If this point we are saying, if this point we have it is minus a comma f of minus a, then this point will be minus a comma minus f of minus a. So this point is flipped to this point, and the graph we obtain in this case, it will be of this form. This is the graph of the function minus f of x. This thing will be more clear to you with the next example. We are saying the graph of the function y is equal to e raised to the power x. This is the graph of y is equal to e raised to the power x. We have to draw the graph of y is equal to minus of e raised to the power x. So what we have done, we have flipped all the points. Flipped the point means corresponding to this point is moved to this is moved to this is moved to this point is moved to this point. So the graph we obtain in this case corresponding to y is equal to minus e raised to the power x, it is this graph. Next we have is, if the function that is given to us, it is y is equal to, we are talking about the next function, it is y is equal to fx, this is given to us, and we have to, the graph of this function it is given, this is given over here, this is y is equal to f of x, or we are talking about this case over here, this is y is equal to f of x. We have to plot the graph of the function y is equal to f of minus of x. So we are saying we have to flip about the y axis. Flip about the y axis means, now this point it is transformed to the point over here, this point is transformed to 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 this. So this is what flip is. We are flipping about the y axis, and the graph we obtain in this case, this is the graph of the function we are obtaining in this case, that is y is equal to f of minus of x. This is graph of this function. Similarly, in this second figure, when we are talking about, this is the graph of the function y is equal to f of minus of x. So how this graph is obtained? We have flipped it along the y axis. We are saying this point is flipped over here, this is flipped over here. Flipped means you can just consider that we have rotated this. We have rotated this like this along the y axis. We have rotated this graph around the y axis. The next example we have in this case, it is, suppose the function we are talking about, it is y is equal to e raised to the power x. So this is the graph of the function y is equal to e raised to the power x. We have to find the graph of y is equal to e raised to the power minus x. So when we are talking about this function, what form is this? We are saying y is equal to f of x is equal to e raised to the power x, y is equal to f of minus x, so that will become e raised to the power minus x. In the previous case we were doing, it is y is equal to minus f of x, the answer was minus e raised to the power x. In this case we are saying we have flipped the graph about the x axis. We have rotated this graph about the x axis. In this case we are rotating the graph around the about the y axis. So this point is mapped over here, this point is mapped over here, this point is mapped over here, and this point is mapped over here. So this is the graph of the function. This graph we are saying, this is the graph of the function y is equal to e raised to the power minus x. Similarly, in the next case we are saying the first graph that we are talking about, it is y is equal to log of x. This is graph of y is equal to log of x. We have to plot the graph of y is equal to log of minus x. So it is the case y is equal to f of minus x. So we have to flip about the y axis. Flip about the y axis means we have to move all these points on this side. We have to rotate this graph in this way. So the graph we obtain over here, that will be of the form this. This is the graph of y is equal to log of minus of x. Next is the graph given to us, it is y is equal to x. We are talking about, this is the line y is equal to x. I am writing it over here. This is y is equal to x. If we have to plot the line y is equal to minus x, it means we are saying the function we have y is equal to fx is equal to x. We are talking about y is equal to f of minus x, that will be equal to minus x. So we are flipping it about the y axis. So the answers we obtain over here, this is the graph corresponding to y is equal to minus of x. So this whole graph, this is the graph of y is equal to mod of x. This is the graph of y is equal to mod of x. Now next thing we have to plot the graph of y is equal to cot x. So we have already seen that the graph of tan x that we have, it is in this form. We are saying this is the line x is equal to minus pi by 2, this is the line x is equal to pi by 2, and we are talking about this is the graph of y is equal to tan x. This line we are talking about, this is the graph of y is equal to tan of x. Now if we write y is equal to tan x, if we are plotting this graph, we are now converting it to y is equal to tan of pi by 2 minus x. If we want to draw the graph of y is equal to tan of pi by 2 minus x, or in place of this we are saying it is x plus pi by 2 say. So the graph we obtain, the graph in this case, when we are saying it is plus pi by 2, so the graph we obtain in this case, it will be of this form. The graph in this case, it will be of this form. We are saying this is the line we are saying. Now this is pi, this is 0, this is corresponding to x is equal to 0, this is x is equal to pi. So what we have done in this case, we are having this point, we are having 0, the value when x is equal to 0, we have the value of y is equal to 0. But now in this case we are saying when x is equal to pi by 2, the value of y is equal to 0. So basically what we have done, we have shifted the graph towards the left. We have shifted this graph of tan x towards the left, and this function is equal to minus of cot of x. Now to remove this minus sign, we flip this graph. We know that when we have to draw the graph for this function, we have to flip it. So all these values, these are flipped, and we obtain the graph of y is equal to cot x in this form. I am again explaining this thing, that when we are writing it is minus of cot x, it means we have to flip the function about the x axis. This thing we have seen over here, when the graph of y is equal to fx is given, we have to plot the graph of y is equal to minus f of x, we have to flip it along the x axis. I am talking about, say, one part of this part I am talking about. This is the graph we have. This is the graph of minus of cot x. We are saying we have to plot the graph of cot x. So when we flip it about the x axis, the graph we obtain over here, it is in this form. So this is the corresponding graph of cot x in the region 0 to pi. So we have started from the graph of tan x. We have moved it by an amount of pi by 2 towards the left. Then we have flipped all these points about the x axis, and we obtain the graph of cot x, and this is the graph of cot x that we have. This is the graph of cot x that we have, and it is clear from this graph what we get is that when we are talking about the point, this is the point 0. So on this side the graph is approaching toward infinity, on this side the graph is approaching towards minus infinity, and when we are talking about the point pi, this graph is approaching towards minus infinity on this side, and this graph is approaching towards infinity on this side. Next we have to plot the graph of cosecant x and secant x. So we are plotting these graphs from the graph of sin x and cos x. We can see over here, we have drawn the graph of sin x first. This is the graph of the function y is equal to sine of x. Suppose I am talking about the graph in the region 0 to pi. I am talking about this graph in the region 0 to pi. I am talking about the graph of sin x. We are saying when the value of x is 0, it is 0. At this point, when the value of the angle it is pi by 2, the answer we obtain it is 1, and the value of angle it is pi, the answer we obtain it is 0. This is x axis, this is y axis. Now we are talking about the function y is equal to 1 over sine of x. When we are plotting the graph of y is equal to 1 over sine x. So what we get is, at pi by 2, suppose I am talking about, the value of sine x is 1. So the corresponding value of cos x will be 1. At pi by 2, we are saying the value of both sin x and cos x, it is 1. Suppose I am moving towards the left hand side. As the value of the angle is decreasing, in case of sine, we are saying the value of the function is decreasing. So it is 1 over sine x, this denominator is decreasing, so it means value of y will be increasing, and as it approaches to 0, we are saying when angle approaches to 0, this value will approach to infinity. So the graph on this side, we are saying it is of this form, that as the angle is decreasing in this direction, the value of the function it is increasing and approaching towards infinity. Similarly, when we are moving towards the right from this point, we are saying the value of the angle as it is, angle is increasing, the value of sine x is decreasing. If the value of sine x is decreasing, it means value of 1 over sine x is increasing, and as it approaches to pi, the value of sine x is 0. So we are saying that it will approach to infinity. So this is the portion of the graph we are considering over here. This is the portion we are saying. Similarly, when we are talking about the region minus 0 to pi, we obtain the graph of cosecant x in this form. Next, in the next region, we are saying it is in this form. Next, it is in this form. So these are the graphs. These graphs that we are showing in red. This is the graph for the function y is equal to cosecant of x. Now from cosecant x, we can obtain the graph of secant x as we have obtained in case of the cos function. We are just shifting all these points, or you can obtain the graph of secant x from the graph of cos x as we have obtained the graph of cosecant x from sin x. So this is the graph of the function y is equal to secant x. So we have seen the graph of sin x, cos x, tan x, cot x, secant x and cosecant x on their domain. Next we have is, if a function y is equal to fx is given and we have to plot the graph of y is equal to mod of f of x. So the procedure to draw this graph is, we are saying we have to reflect the parts of the graph that lie on the lower half, negative parts we are saying, into the upper half of the axis, because it is mod over here. If I am talking about the function y is equal to x, we are saying the graph of this function y is equal to x, if we plot, it is in this form. Now if I am talking about y is equal to mod of x, it means the values of y, they are always positive. The value of y, it is always positive for all values of x. So we are saying first thing we are going to do is we are going to remove this portion. And how this portion will behave now? This will be reflected on the upper part. We have reflected this portion along the x axis, and we obtain the graph of y is equal to mod of x. So same thing we are talking over here. If the function given to us, suppose this is the graph of the function y is equal to f of x. In this graph we can see that this is the negative portion we have, this is the negative portion we have. We have to reflect this portion along the x axis. So when we reflect this portion we obtain this, when we reflect this portion we obtain this. So we are saying this portion of the graph will remain as it is. We are talking about this portion of the graph, this will remain as it is. We have reflected this portion over here and this second portion over here. Similarly, we are talking about the function y is equal to mod of log x. The graph of log x is, y is equal to log x is this. We are saying that this portion is the negative portion. We have to ignore this portion and we have to basically reflect this along the x axis. So this portion when reflected along the x axis we get this line over here. So this is the graph of y is equal to mod of log of x. Similarly, next we are talking about the function given to us, it is y is equal to sin x. This is the graph of the function y is equal to sin of x. Now if we look at the negative portions over here, negative portion means we are talking about this portion, this is below the x axis. We are talking about this portion, this is below the x axis. We are talking about this portion, this is below the x axis. We are talking about this portion, this is below the x axis, and we have to reflect this portion. We have to reflect this portion along the x axis. So the new portion that we obtain from this, we are obtaining, this is the reflection of this first part, this is the reflection of this second part, this is the reflection of the third part, and this is the reflection of the this part over here. So this is the graph of y is equal to mod of sin x. So these are the image of the portion below the x axis, and the image we are taking, it is along the x axis. Next is the function that is given to us, it is y is equal to fx. If the graph of y is equal to fx is given, we have to plot the graph of y is equal to f of mod of x. So this is different from the previous case. In the previous case we are saying y is equal to fx is known. We are plotting the graph of y is equal to mod of fx. Now in this case we are calculating the graph of y is equal to f of mod of x. So what we have to do over here is, we are saying discard the left part of the graph for x is less than 0. In that case, in this case, we have discarded the part for which y is less than 0. We have taken the reflection along the x axis. In this case, we are discarding the part that is x is less than 0, and we take the reflection of the right part of the graph into the left part half of the axis. So what this thing means is, if the graph of log of x is given, we are saying this is the graph of the function y is equal to log of x. First thing is that there is no value for which x is less than 0. This function is not defined for x is less than 0. So this part is not there. Now next thing we have to do is, we have to reflect this whole right part on the left portion. So when we reflect this part over here, we are saying we have to reflect all these points over here. So the graph we obtain by this reflection, it is of this form. So this is the graph of the function y is equal to log of mod of x. Next is the graph of y is equal to e raised to the power x. This is the graph of y is equal to e raised to the power x. We have to neglect the portion for which the values of x they are negative. The value of x are negative for this portion. So we have neglected this part. Next, we have to take the reflection of this line along this y axis. So we obtain this portion of the graph. So this is the graph we are obtaining for y is equal to mod of e raised to the power mod of x. This is the graph for y is equal to e raised to the power mod of x. Next we are saying, if the graph of y is equal to mod of fx is given, this is the graph of the function y is equal to mod of fx, we have to plot the graph of y is equal to mod of f of mod of x. So what we have to do is, we have to ignore or discard this negative part. This negative part we are saying we have discarded, and we have to take the image of this part on this side. This part of the graph, it is already there. When we take the image of this part on this side, the image of this v, this will be over here. This is the image of this part, and image of this line, that will be this line over here. So this is the graph of the function y is equal to mod of f of mod of x. Similarly, the graph of y is equal to sin x. This is the graph of y is equal to sin of x. If we have to plot the graph of y is equal to sin of mod x, we are saying the negative part we have over here. This is the negative part we have. We are neglecting this negative part. Now I am talking about, this is the graph of sin x in this portion 0 to pi by 2. We have neglected the negative part, and the reflection of this part will be in this form. Next we are saying it is continuing like this, and the reflection of this portion will be like this. So this portion we are obtaining over here in this form. This is the portion we are talking about, that will be changed over here. So this is the graph of y is equal to sin of mod of x. Next we have, if the function y is equal to fx is given, and we have to plot the graph corresponding to mod of y is equal to f of x. So we are saying, what we have to do is, we have to discard the lower part of the graph f of x is less than 0. When we are talking about y is equal to fx is given, and we have to plot the graph of y is equal to f of mod of x, f of mod of x, then what we have done, we have neglected the part of graph for which x is less than 0. We have neglected this portion of the graph for which x is less than 0, and take the reflection of the right part of the graph into the left hand of the axis. Now we are talking about the case when it is y mod of y is equal to f of x. So what we have to do is, we have to neglect the lower part of the graph, that is for which fx is less than 0. We have to neglect this part, and we have to take the reflection of upper part of the graph in the lower half of the axis. So this thing is explained over here with the example. Suppose the first case we are talking about, the graph of the function y is equal to fx is given. This is the function y is equal to fx. We have to obtain the graph of mod of y is equal to f of x. So first thing we have to see is, what are the values for which fx is less than 0. So we are saying this is the portion of the graph for which fx is less than 0. So we are neglecting this portion. After that, we are taking the reflection of this portion of the graph. We have taken the reflection of this portion of the graph about the x-axis. This is the reflection of this portion over here. and this is the required graph for this whole graph we are talking about. This is the graph of mod of y is equal to f of x. Suppose we are talking about the equation of the line that is given to us. This is the line we are talking about. It is y is equal to x minus 1. This is the line we are saying. This is y is equal to x minus 1. If we have to plot mod of y is equal to x minus 1, what we are going to do is we are going to neglect this portion. Because for this portion fx is less than 1. We are going to take the reflection of this portion along the x-axis and we obtain this line over here. So this is the graph for the function mod of y is equal to x minus 1. Similarly, the next graph we are talking about, the graph of sin x. We know that the graph of sin x, it is of this form. This is the graph of sin x. Now if we have to plot the graph of, this is the graph for the function, we are saying this is y is equal to sin of x. Now if we have to plot the graph of mod of y is equal to sin of x. So first of all we are talking about the negative portion over here. This is the negative portion we are talking about, this portion of the graph. This is the negative portion. We are neglecting this portion. By neglecting this portion, this graph comes in the form, this is our x-axis, this line is over here. So we are left with this, then next it is this, over here we have this. When we have neglected these negative values, we obtain the graph in this form. Now we have to take the reflection of this graph about the x-axis. When we take the reflection over here, we obtain reflection in this form, reflection in this form, and reflection in this form. So the final graph for mod of y is equal to sin x we obtain in this form. Next is, if the line equation of this line is given to us, it is y is equal to 1 minus x. We know how we can plot this, the graph corresponding to this. We can substitute different values of x. We are saying when x is equal to 1, y is equal to 0, and when y is equal to 1, we obtain x is equal to 0. So we can plot this line over here. We have plotted the equation of this line. It is y is equal to 1 minus x. Next thing we have to do is we have to plot the equation of y is equal to 1 minus mod of x. So we are saying the function we have, it is f of x. Y is equal to f of x is equal to 1 minus x. Now we are plotting the function y is equal to f of mod x, that is equal to 1 minus mod of x. So to plot this, we are saying we have to neglect the portion of the graph which is negative. This portion of the graph, this is negative, we have neglected this portion. We have to take the image of this portion of the graph over here, and we obtain the graph in this form. So this is the graph of the equation y is equal to 1 minus mod of x. Next thing we are going to do over here, we are saying now we have the graph of, this is the graph of y is equal to 1 minus mod of x. Now if we have to plot mod of y is equal to 1 minus mod of x, we have to plot mod of y is equal to 1 minus mod of x. So we are saying this is the negative portion over here, this is the negative portion over here. We have to neglect these portions and we have to take the image of these portions. The image of this portion will be in this form, and image of this portion we are saying it will be in this form. This is the image of this portion of the graph. So we are saying the final answer we obtain, this portion is neglected, this portion is neglected, and we are left with this graph over here. This is the graph we have obtained over here, and the equation corresponding to, this is the graph corresponding to the equation mod of y is equal to 1 minus mod of x, that is mod of x plus mod of y, that is equal to 1. So this is the graph of this equation. Next, suppose the graph corresponding to the equation y is equal to x minus 1 is given. This is the line we are talking about. This is the line y is equal to x minus 1. Now if we are plotting the line y is equal to mod of x minus 1, so what we have to do, this is the negative portion over here. We have to discard this portion and we have to reflect this remaining portion on this side. When we reflect this portion on this side, we obtain the graph in this form. So we obtain the graph, this is the graph we are saying for y is equal to mod of x minus 1. Now we have to plot mod of y is equal to mod of x minus 1. We have to plot this. So we are saying to plot this portion, we are neglecting this portion of the graph and we are reflecting this portion. So first we are talking about this line over here. We are removing this line and the reflection of this line in this form. We obtain the reflection of this line in this form. When we are talking about this line over here, the reflection of this line will be in, this is the reflection of this line over here. So that graph we obtain, this is the graph we are talking about. This is the graph corresponding to the equation mod of y is equal to mod of x minus 1. Now the next question we have to plot the curve y is equal to mod of y is equal to mod of sin x plus 1 by 2. So to plot this, first of all we have drawn the curve y is equal to sin x. This is the curve we are saying, this is corresponding to y is equal to sin x. On this curve we have at 0 the value is 0, at angle pi by 2 the angle value is 1, at angle minus pi by 2 the value is minus 1. Next thing we are going to do, we are going to draw the graph of y is equal to sin x plus 1 by 2. It is plus 1 by 2, it means the graph will be shifted upward by an amount of 1 by 2. So earlier this point was 0 over here, so this point is shifted to the point 1 by 2. This was having the value 1, so this point is shifted to the point over here, this is 3 by 2. This is the value minus 1, this point is shifted over here to the point minus 1 by 2. So we have obtained the graph corresponding to the function y is equal to sin of x plus 1 by 2. How this graph is there? We are saying now this is the x-axis and whole of this graph it is shifted upwards by an amount of, by a factor of 1 by 2. Next we are going to plot the graph corresponding to y is equal to mod of sin x plus 1 by 2. So for this we are saying this is the lower part of this graph, this is the part of the graph which is below x-axis. We have to discard this part of the graph and we have to take the image of this portion along the x-axis. So if I am talking about this portion over here, earlier this was the portion over here, we have discarded this portion. Earlier this was the portion over here, we have discarded this portion. This was the portion over here, we have discarded this portion, and these are the images of these portion along the x-axis. These are the images of these portion. So this is the graph corresponding to y is equal to mod of sin x plus 1 by 2. Next thing we have to do is we have to plot mod of y is equal to mod of sin x plus 1 by 2. Now there are no values, in this case we are saying there are no values for which fx is less than 0. So there are no values to be discarded, but what we have to do, we have to take the reflection of this whole graph about the x axis. We have to take a reflection about x axis. So when we reflect all these points about x axis, we obtain the graph in this form. This is the reflections we are talking about of this original graph about the x axis. So this is the graph for the function y is equal to mod of y is equal to mod of sine of x plus 1 by 2. Next is we have to plot the graph of y is equal to greatest integer of this function that is given to us. It is greatest integer function. It is greatest integer of sine x. So the graph of sine x, we know this is the graph of the function y is equal to sine x. Now we are talking about the greatest integer of sine x. Now if we look at the values over here, we are saying when the values of x lies between 0 to pi by 2, or we are saying they are lying between 0 to pi, the answers for sine x, they lie between 0 and 1, and the value will be equal to 1 only at the point pi by 2. So we are saying at pi by 2 the answer will be 1. For the values between 0 to pi by 2 union pi by 2 to pi, the answer will vary between 0 is less than equal to sine x is less than 1, and the greatest integer of these values, the greatest integer value corresponding to this interval, that will be 0. So we are saying for all these points between 0 and up to this, at this point the value is 0 over here. This is the point corresponding to pi by 2, the answer it is 1. Then again it is a straight line over here. Similarly, if we move in the previous quadrants, we are talking about the value from minus pi to 0. We are saying at minus pi by 2 the value of the function it is minus 1, and between all these values the value of the function that will be equal to minus 1. So we are saying all these values, these are in this form. At this point the value is over here, this is hollow over here, this is hollow over here, the value is over here. So if we repeat this graph again and again over here, we obtain the graph of this function in this form. These are shown over here. We are saying this is dark, this is dark, this point is not included, this is dark over here, the values are between these two values, these values are between these values, these values, these are not included over here. So likewise we can plot the graph of the function y is equal to greatest integer of sine of x. Next is plot y is equal to sine of greatest integer of x. So when we are talking about y is equal to sine of greatest integer of x, so greatest integer of x, we are talking about the values of x. So if we look at these values of greatest integer of x, the values of this greatest integer of x that it can take, it is 0, minus 1, minus 2, 1, 2, 3. So we are talking about these values over here. We are talking about the greatest integer 1, 2, 3. Then it is minus 1, minus 2, minus 3. So if we look at the value of pi by 2, that is equal to 3.14 divided by 2. So that point will lie somewhere over here. This will be the value pi by 2. Similarly, when we are talking about the value pi, it is 3.14. The value pi will lie somewhere over here. We are not talking about that these are the integer points. We are talking about the values of greatest integer of x. They can be this, it can be this, it can be this, it can be this. We are saying the value of x, this 0 value will be when x belongs to the interval 0, 1. We are talking about this region over here. We are saying when the value of x, it lies between 0 and 1, the answer we are talking about, it is 0. Greatest integer of x will be 0, and for this value, the value of the function sine of greatest integer of x, that will be 0. So we are saying in the region 0 to 1, the answer we have, it is 0. Now at the point 1, when we are talking about, the answer changes to 1. When we are talking about x is equal to 1 to 2, the greatest integer of x will have value 1, and the value of function will become sine of 1, and this will go up to pi by 2. We are talking about this, we are not talking about the interval 0 to 1 to 2, we are talking about the interval 1 to pi by 2, because at pi by 2 the values will start decreasing. So we have obtained that the answer we will have over here, it will be equal to something like sine of 1. So these are the values we are talking about. Then for pi by 2 the answer will be over here. Then for all other values the answer will be like this. Then the values will change at this point over here at 3 to 4, the answer will be in this form. Suppose I am talking about this interval, I am saying 3 to 3.14. We are talking about the values of x, they belong to 3 to 3.14, or we are writing it as pi. This value we are talking about, this is the point 0 we have. We are saying for all these values, the greatest integer of x, that will be equal to 3, or we are saying for all the values from 3 to 4 open interval, the greatest integer of x is 3, and the value of this function will be sine of 3. So these are the values we are talking about. Corresponding to 3, the value of the function, it is sine of 3. It is still positive. Next, when we are talking about the values that are lying between 4 and 5, if x belongs to closed interval 4 and open interval 5, the greatest integer of x will be 4. The answer we obtain, that will be sine of 4. Sine of 4, when we are talking about this, 4 is greater than pi, so the answers we obtain, that will be negative. So we are saying this value sine of 4 is basically negative. This point 4 has this value, and it is up to 5, and it is open at this 5. So this is the graph. This is how we can plot the graph for y is equal to sine of greatest integer of x. Next, we have to plot the graph of y is equal to greatest integer of sine of greatest integer of x. We have already seen that the graph of this sine of greatest integer of x, when we are talking about y is equal to this, then that graph is of the form I am drawing over here. This is from 0 to 1, the values are over here. Then we have the values, they are equal to these values, these are equal to sine of 1. Then somewhere over here we have the values, they are equal to these values, these are equal to sine of 2. Then next we are saying the values will start decreasing, and we have the values over here, they are in the form of sine of, these values we are saying these are in the form of sine of 3, and likewise this graph will continue. We obtain the graph in this form, and these are the values we are saying, these are from 0 to 1, and then this is corresponding to 2, then this is corresponding to 3, and then we are saying this is corresponding to pi we are having. So this is the graph we have. I am again drawing these points over here. This point it is included, then this, and then this. Now we have to plot the graph of, this is the graph for the function y is equal to sine of greatest integer of x. Now we have to plot the graph of y is equal to greatest integer of sine of greatest integer of x. Now we have to plot the graph corresponding to this. So if we take the greatest integer values over here, so we are saying that all these values, when we look at the maximum value we can have over here, the value of this sine of greatest integer of x, if I am talking about, this is always in this interval, I am saying 0 to pi, this is always lying between is less than equal to 0 and is less than 1. So if we take the greatest integer of this function, we are talking about greatest integer of sine of x, this will always has the value equal to 0. So the graph of the function y is equal to greatest integer of sine of greatest integer of x, that will always be equal to 0. This graph, it is depicted, shown over here. We are saying it is y is equal to greatest integer of sine of greatest integer of x. So its value is always equal to 0 in this region. Next we have is to plot y, the greatest integer of y is equal to sine x. So when we are talking about this function, it is greatest integer of y is equal to sine x. So first thing is the points that we have over here, the answers we require, that should be this value, greatest integer of y. These are basically the integer values, and we know that sine x will attain the integer values as -1, 0 or 1. If suppose I am talking about these values, sine x will attain the value 0 at the point 0, then it will attain this value 0 at the point pi, then 2 pi. Similarly it will attain the value at, we are saying it is plus minus, at all these points the value of this function, this will be 0. When we are talking about the value 1, the value 1 will be attained at pi by 2, 5 pi by 2 and all these points, and value -1 will be attained at, it is 3 pi by 2, minus pi by 2, at all these points the values will be -1. For all other values, these values cannot be the integer values, so the domain of this function, it is only these points over here. So how we can plot these points now? We are saying corresponding to 0 the value is 0. I say corresponding to 0 the value is 0. Now we are talking about, this is greatest integer of y over here. We are interested in those values of y for which greatest integer of y is 0. It means this y belongs to 0 is less than equal to y is less than 1. So we are saying this is the portion we are showing over here. This is the value 0, this is the value 1, this is the point 0, 0. Next we are saying, we are talking about the point pi by 2. At this point the answer it is 1. So we are saying greatest integer of y should be 1. It means 1 is less than equal to y is less than 2. So this point is, suppose this point it is pi by 2. At this point the value of the function it is 1, and we are saying that the values of y, possible values of y, they are varying from 1 to 2. These are the possible values of y that we have in this case. Next, when we are talking about the point pi, next we are talking about the point, it is pi over here. Again at this point pi the value can be 0. In this case we are saying the value we require it is 0. So the value of y, it is varying from this to this. So we obtain the graph over here in this form. Next it is 3 pi by 2. For 3 pi by 2 we are obtaining the value of greatest integer of y should be equal to -1. It means -2 is less than y is less than equal to -1. So the graph for corresponding to the point, this is 3 pi by 2 we are saying, so it will be of this form. So likewise we can continue and we obtain the graph for greatest integer of y is equal to sine x. These are the this is the graph corresponding to this function. Next is suppose the function y is equal to fx is given to us and the graph of this function is given. We have to plot the graph of the function y is equal to k times f of x. So the procedure is we have to stretch or compress the graph along the y-axis depending upon whether k is greater than 1 or k is less than 1. And if k is negative, we have to flip the graph along x-axis. So this thing is shown over here. We are saying this is the graph of the function y is equal to fx. This is graph of the function y is equal to f of x. We have to plot the graph of the function y is equal to a times f of x, where a is greater than 0. It means what we are going to do is we are going to stretch this graph. What stretch means? Earlier, suppose at this point the value of the function, this was f of 0. Now the value of the function, it is a times f of 0. So this value it has increased. We are saying at the point x is equal to, we are talking about those points x, say it is b, for which f of b is equal to 0. Then corresponding to this function, we are given the function y is equal to a of x. So we are saying y is equal to a times f of b. If f of b is equal to 0, then the answer will remain same. It means those points which lie on the x-axis, they will be fixed over here. These points which are lying on the x-axis, they are fixed over here. If we consider any point, if we are considering the point corresponding to any other point except these 2 points, we are saying the graph is stretched in this case. Similarly, we are talking about the function y is equal to 1 by a of f of x. 1 by a of f of x means, suppose I am talking about it is y is equal to 1 by 2 times fx. So what we are saying over here, earlier the value of the function, say it is 1. This is the graph corresponding to y is equal to f of x. Suppose this point we are saying this is the point a. So the value of the function at this point, it is f of a. Now the function it is multiplied with 2. So the height now we have, it is 1 by 2 times f of a. So this height is being reduced. So we are saying we have compressed the graph in this case. This will be more clear to you with this example over here. We are saying, suppose this line is given to us. It is y is equal to x we are talking about. This is the line y is equal to x. If we have to plot y is equal to 2x, so we are saying first of all we have to find the points which are lying on the x-axis. This is the point lying on the x-axis. This will remain fixed. Now any other point over here, that will be, the value corresponding to that point will be increased. If suppose I am talking about x is equal to 1, the value of the function over here, it is 1. Now if I am talking about the line y is equal to x is 2x, the value of y over here, it is 2. So we have, what we are saying, that this graph it is being stretched. And if I am talking about y is equal to 1 by 2x, then corresponding to this value we will have the value 1 by 2. Corresponding to x is equal to 1, we will have y is equal to 1 by 2. So this graph is basically compressed. So this is how we can obtain the graph in these cases. So we are talking about another example over here. So we are given the function y is equal to sine of x. This is the function y is equal to sine of x. We are saying we have to plot y is equal to 1 by 2 sine x, and we have to plot y is equal to 2 times sine x. So first thing we are going to do over here, we are going to mark the points where it is intersecting with the x-axis. These are the points. These will not change. We are saying if I am talking about this portion of the graph 0 to pi, both these points will not change. This is corresponding to the function y is equal to sine x. Now if I have to plot y is equal to 2 sine x, what we get is the value at pi by 2, it is earlier it is 1. Now the value of this function, if we substitute x is equal to pi by 2, the value of the function will become 2. It means the graph is basically stretched in this portion. This thing is shown over here. In this case we are talking about that the graph of this portion, it is stretched. Now if we are talking about y is equal to 1 by 2 times the sin x, earlier the value was 1, now the value should be 1 by 2. So the graph of this function, it will be compressed. So we are talking about this case over here, that this is the portion of the graph we are saying. This is corresponding to y is equal to 1 by 2 times sin x, and this portion is compressed. It is important, I am again mentioning over here that both these points, these are fixed, because for these points the value of y is 0. So if we multiply it with 2, the answer will not change. So these points will remain fixed, and for all other points the graph will either expand or graph will either shrink. And it depends upon the value of k that we have, that if the value over here we have it is less than 1, the graph will be shrinking or it will be compressed, and if the value of k is greater than 1, then we are saying the graph will be expanded. Another thing that we have already mentioned is that if the value of k is negative, then we have to flip the graph. We have to flip the graph about x-axis, and this case we have already studied when we were talking about that y is equal to fx is given, and we are talking about y is equal to minus f of x. This minus is basically, we are saying it is minus of 1. Now we are talking about the cases. We are saying y is equal to k times fx. We are talking about two cases over here. Either k is positive or k is negative. Further, we are having the case when k is 1 or k is minus 1. So this k is minus 1 case, this we have already studied, that y is equal to minus f of x. This we have already studied. Now we are talking about mod of k is greater than 1 or mod of k is less than 1. So it will shrink or expand. Next is y is equal to fx. The graph of this function is given. We are talking about y is equal to fx. This is the graph of the function y is equal to fx. We have to plot the graph for the function y is equal to f of kx. So again we are having two cases over here. We are talking about y is equal to fx is given. We have to plot y is equal to kx, the f of kx. Again we have two cases over here. One is when mod of k is less than 1, and second is when mod of k is greater than 1. We are saying the case when k is equal to minus 1, this we already have studied, and in this case what we have to do is we have to flip about the y-axis. This case we have already studied. So first of all we are looking at the case when k is greater than 1. Now in the previous case, when we were saying the graph of y is equal to fx is given and we have to plot y is equal to k times fx, we were stretching or we are doing the compression of the graph along the y-axis. Now we are doing the compression or stretching of the graph about the x-axis. So we are talking about the case when k is greater than 1. So we are saying this point over to 0, this will remain fixed in this case. Now k is greater than 1. So what we have done, we have stretched this graph over along the x-axis. We have stretched this graph along the x-axis. This thing will be more clear to you with this example. We are saying the graph of the function y is equal to sin x is given. This is the graph of the function y is equal to sin of x. Now what we are going to do, we are going to plot the graph corresponding to y is equal to sin of 2x. We are saying when x is equal to 0, when x is equal to 0, we will have the value of y is equal to sine x, that is equal to y is equal to sine of 2x, that will be equal to 0. So this point over here, this will remain fixed. When we are saying x is equal to pi by 2, the value of y is equal to sine x, we are calculating the value of this, and we are calculating y is equal to sine of 2x. So we are saying this value is equal to sine of pi, this value is equal to sine of pi by 2. So this answer it is 1 and this answer it is 0. So we are saying earlier at the point pi by 2, this point we are saying earlier at the point pi by 2, the answer we were having it is 1. Now at the point pi by 2, the answer we have 0. So we are saying the next thing we are talking about, earlier at this point the answer was becoming 0 corresponding to the point 0. Now look at these conditions over here. What we are saying, earlier the graph of sine x at point 0, the answer it is 0. We are saying it was increasing and then decreasing up to pi by 2, it was increasing and then it was becoming 0 at the point pi. Now what is happening over here, we are saying it is the value of this function is becoming 0 at x is equal to pi by 2. It means it is shrinking faster. At pi by 2, the answer is becoming 0. It means the graph in this portion, it is shrinked along x axis. So we obtain the graph corresponding to, this is the graph for y is equal to sine x and this is the graph for y is equal to sine of 2x. So this portion is shrinking along x, we are saying we are compressing the graph along x axis. Y axis, we are saying this height, these heights over here, they are same 1. The portion that is shrinking, earlier it was becoming 0 at pi, now it is becoming 0 at pi by 2. So it is shrinking towards the x axis. Next case we have when the value of k is less than 1 and greater than 0. So we are saying this is the graph we are talking about. This is the graph of the function y is equal to fx. Then in this case the graph will expand along the x axis. Again we are explaining this with the help of this example. The graph of y is equal to sine x. This is the graph of y is equal to sine x. Suppose I am talking about the interval 0 to, I am talking about the interval, it is 0 to pi, the graph of sine x, or say pi by 2, the graph, this we are talking about the interval 0 to pi, this is the graph of sine x. Now at the point x is equal to 0, we are saying the value of y we have, that is equal to 0. We are talking about the function y is equal to sine x or y is equal to sine of 2x. In both these cases the answer is 0. But when we are talking about the function y is equal to sine of 2x, we are saying if we consider x is equal to pi, then the value of y will be sine of 2 pi and the answer we obtain it is 0. But now we are considering the case when the function y is equal to sine of pi by 2. We are talking about if we consider x is equal to pi, the function, two functions we are talking about, one is y is equal to sine x and one is y is equal to sine of x by 2. Now corresponding to this first function, the value of y we obtain it is 0. Corresponding to this second function, it is sine of pi by 2, that is equal to 1. So we are saying that this function, the value at pi by 2, it is still 1. So the graph in this case, this value, this will become 0 at the value 2 pi. If we consider x is equal to 2 pi, then the value of y of sine of x by 2, that is equal to sine of pi, that will be equal to 0. It means earlier this function, when we are talking about this function was becoming 0 at the value pi. Now in this case it is being stretched and this function is becoming 0 at the value 2 pi. So the graph of this function, if we look at, we are saying the graph of this function, it is stretched along the x-axis. Stretched along the x-axis means earlier this value was 0 over here, then it was 0 at pi. Now this point is being shifted to the point 2 pi. So this portion of the graph, it is stretched as this portion of the graph. The maximum value we are talking about, it remains 1. So this portion is stretched in this case. Next is we have to plot y is equal to 5 sine 2x plus 4. So we start plotting this graph with the graph of sine x. So the graph of sine x, we are plotting it in the region 0. This is pi and this is 2 pi. Now we have to plot, this is the graph of y is equal to sine of x. Next thing we have to do is we have to plot the graph of y is equal to sine of 2x. Now we know that if we plot the graph of y is equal to sine of 2x, this graph will be shrinked, the maximum value will remain same, and this graph will be shrinked, and we obtain the graph of this function as, this is the graph of y is equal to sine of 2x. Next thing, we are plotting the graph of y is equal to 5 times sine of 2x. So we are saying this value is multiplied with 5 over here. It means this graph will expand along the y-axis. These points will remain same and this graph will be expanded along the y-axis. So we obtain now the first this graph we are obtaining over here, it will be of this form. This value over here, it will be 5. This value over here, this will be corresponding to minus of 5. This points, these are the points we are talking about. Next thing we have to do is we have to plot the graph of y is equal to 5 sine 2x plus 4. So we are adding 4 to it. It means this whole graph will be shifted upward by 4 units. So this point, it is minus 5. It will be shifted to the point minus 1. This is the point 0. This will be shifted to the point 4. So now the graph will start from the point 4, move up to minus 1 and go up to the point. This point will be shifted to 4. The 0 will be shifted to 4. Minus 5 will be shifted to minus 1. So we obtain the final answer in the form this, that the graph is starting from the point 4, then it goes up to 9. Now the maximum value, it will become 9, then it will decrease, and this is the graph of the function y is equal to 5 sine 2x plus 4.